After every, we decreased HRT gradually in a stepwise fashion, where after every HRT reduction follows an increase in the MTB concentration in all 4 compartments. But we have very high HRTs, which are 0.6 and 0.3, a significant increase compared to the others. This is because very low HRTs, as you can see here, a small decrease in the HRT results in a very big increase in the volumetric flow rate. And at the plot below, you can see the biomass of the bioreactor, and you can see that the bioreactor is up to this point overloaded and full loaded. And effluent MTB concentration, you can see that it's for most of the time below the discharge limit. This again the red solid line. So based on the simulations, the packed-bed bioreactor will reach a maximum biomass concentration after a certain period of time, and then it will remain constant, and we have then free cells in the outlet. So the HRT can be systematically reduced to a minimum value that corresponds to the maximum biomass concentration, and whenever this is done, we should wait for a period to see whether the system reaches a steady state, which means whether the effluent concentration will be below the limit. So it is better to reduce HRT gradually rather than in big steps. And in real-life operation, the bioreactor's performance is much more complicated. For example, we can have blacking due to excessive biomass increase, and thus channeling flow resulting in nutrient limitations in certain areas. And here you can see an idea, a simple rule we have to decrease the HRT for the system. When we are at steady state, all the incoming MTB into the system is biodegraded and converted to additional biomass. So we have unexploited biomass for this HRT, which means that the system is capable to degrade much more MTB. As biomass increases, the MTB effluent concentration is decreasing beyond the limit, and hence we could increase the volumetric flow rate and stay within the limit. It can be shown that the increase in the volumetric flow rate can be computed from this equation, where you can see that we need biomass measurements. And since we want to avoid these measurements, we can only monitor the MTB effluent concentration, and whenever it drops below 20%, we could increase the volumetric flow rate by a specified small amount. So as conclusions, during the operation of packed there is a continuous biomass build-up, and when biomass increases substantially, we can lower hydraulic residence time, increasing the inlet flow rate. During the first 130 days, we do not have any cells in the effluent, and at this point, the bioreactor is essentially at full capacity, and we cannot reduce HRT further. Thank you very much.
Thank you very much. I think we have time for 1 or 2 questions. Any questions from the audience? So I will have a very small question. You did not include any internal mass transport process in your model.
No, mass transfer is our next step.
Do you think that it will, but since I've seen that your model predicts an increase in the biomass in the system, so it is reasonable to expect that internal mass transport phenomena could require an appropriate modeling. So
mass transfer is very important, and we will included in the next
Next.
slide.
Thank you very much.
Thank you.